All right, in this video, we're going to talk about data distributions and outliers. So an outlier is a value in a set that is much greater or much less than most of the other data. We can actually calculate if a number is an outlier by taking my quartile 1 value and subtracting 1.5 times my interquartile range. So I'd find my IQR, I'd multiply it by 1.5, and I would subtract that value from quartile 1. That would give me if it's really, really low. And then if I wanted to find the upper outlier, I would take quartile 3 and I would add 1.5 times the IQR. Any values that are outside of those fences would be considered outliers. All right, so a dot plot is a data representation that uses a number line and dots, x's, or some other symbol to show frequency. So how many times did that number occur? So here's an example of a dot plot. All right, comparing distributions. A data distribution can be described as symmetric, which is normal, skewed to the left or skewed to the right, depending on the general shape of the distribution in a dot plot or other data display. So if I'm looking at this first dot plot, it is skewed to the left. Okay, if you can kind of draw a curve over it, you can see that the tail part of the graph of that curve is on the left side. So that's why it's skewed to the left. More than half of the data is greater than the mean. A symmetric distribution is a normal model, follows a normal model. Symmetric means you can kind of fold it in half and it would match up with itself. The data is evenly distributed about the mean. And then skewed right is the tail is on the right side and more than half of the data is less than the mean. All right, we said the symmetric one is our normal model. All right, example 1. The average bowling score for a group of bowlers is 200, 210, 230, 220, 230, 225, and 240. They want us to create a dot plot. Well, my smallest number is 200. My largest number is 240. I'm going to count by fives. So 200, 205, and so on, all the way up. And then I'm going to put my dots there. Well, 200 occurred once, so I have one dot for that. 210 occurred once, so one dot for that. 220 occurred once, 225 occurred once. 230 occurred twice, so I have two dots there, and 240. Suppose that a new bowler joins the league and has an average score of 275. Is that bowler an outlier? All right, so I'm going to take all my data values that I was given before, and I'm going to find the median and the IQR. So I'm going to find the median, which is 225, the middle number. Then I'm going to find the first quartile and the third quartile. Quartile 1 is 210. Quartile 3 is 230. So IQR is Q3 minus Q1. So it's 20 minus, it's 230 minus 210, which is 20. Now I need to determine if it's an outlier. Okay, so I'm looking at the higher number, 275, so I'm going to take Q3 and add 1.5 times my interquartile range. Well, my IQR was 20 and Q3 was 230, so it'd be 230 plus 1.5 times 20. Well, 1.5 times 20 is 30. 230 plus 30 is 260. So any value over 260 is an outlier. Therefore, 275, yes, that is an outlier. All right, example 2. A school fundraiser sells magazines and coupon books. The number of magazine and coupon books sold was recorded. Compare the statistics for both magazines and coupon books. So they gave me the mean number of books sold, the median number of books sold, the IQR, the interquartile range of the spread, and the standard deviation of the spread. Now, if you look at this, you'll see that the mean and median for magazine subscriptions is a lot higher than it is for coupon books. This means that there are more magazines sold than coupon books. Also, you notice that the mean and the median for both magazine subscriptions and coupon books, they're pretty close together. 70 and 72, not that far apart. 48 and 49, those are pretty close together. Also, you might notice that the spreads, the IQR and the standard deviations, are about the same for both types of fundraisers. So there's not a huge variation in how spread out the sales were. All right, your turn. The frequency table shows the number of miles walked by members of a fundraiser. Make a dot plot to describe this distribution. So here's our frequency table. We're going to make a dot plot. So I have 6 that went 1 mile, 7 that went 2 miles, 4 that went 3 miles, 2 that went 4 miles, and 1 that went 6 miles. Okay, they wanted us to describe it. So this distribution is skewed to the right. Okay, you can see that the tail's kind of being pulled over toward the right. How many miles would someone have to walk to be considered an outlier? All right, well, here's all the miles. I had 6 1s, 7 2s, 4 3s, 2 4s, and 1 6. So I'm going to find the median, which is in between a 2 and a 2, so it's 2. Then I'm going to find the quartile 1, which is 1, quartile 3, which is 3, and now I can find the IQR. So Q3 minus Q1 gives me 2. My outlier fences is going to be Q3 plus 1.5 times my IQR. So it's going to be 3 plus 1.5 times 2. 1.5 times 2 is 3. 3 plus 3 is 6. Okay. Now the reason I'm not doing my lower quartile is because we're not going to have a negative outlier. Okay, you can't go negative miles. So I don't have to worry about doing the other way. Therefore, anybody that walks more than 6 miles would be considered an outlier.